NASA didn't see it. James Webb missed it. But a small observatory, hidden deep in the mountains of Brazil, just exposed something no one expected. A mysterious interstellar visitor thought to be dead, suddenly waking up. A faint tail, tilted in the wrong direction, breaking every rule of comet physics. Why didn't NASA tell us? And what exactly is 3I/Atlas hiding? For months, 3I/Atlas was treated like a cosmic footnote, the third interstellar object ever detected in human history, yet somehow the least exciting of them all. To most astronomers, it was nothing more than a cold, dim wanderer, a ghost from another star system drifting silently across our skies. It didn't behave like Oumuamua, the first interstellar visitor, which sparked global headlines when it accelerated in ways we couldn't explain. And it didn't blaze like 2I/Borisov, which lit up the darkness with a classic comet tail that stretched for millions of kilometers. Compared to them, 3I/Atlas was boring. A dot of light, catalogued, plotted, and quietly filed away. When scientists trained their billion-dollar instruments on it, the results seemed almost disappointing. No tail, no outbursts, no irregular movement, just a speck moving on a hyperbolic orbit, destined to slip back into interstellar space, gone forever. Most people never even heard its name. And for those who did, 3I/Atlas felt like a story that had already ended before it began. A rock from nowhere, going nowhere. But the universe rarely leaves us with clean, predictable answers. Sometimes, the most unremarkable things are the ones hiding the biggest secrets. Because while the world dismissed 3I/Atlas as silent and lifeless, deep inside it was changing, waiting, preparing. And then, one quiet night, that silence shattered. The breakthrough didn't come from NASA, or the James Webb Space Telescope, or even the European Southern Observatory. It came from somewhere no one expected, the quiet hills of Minas Gerais, Brazil. There, far from billion-dollar budgets and international headlines, sits the Southern Observatory for Near-Earth Asteroid Research, better known as SONIER. It's not flashy. It's not government-backed. It's a modest facility run by astronomers who live for the sky, working with limited resources but unlimited persistence. On the night of August 23, 2025, veteran astronomer Cristóvão Jacques was tracking 3I/Atlas as part of a routine scan. He had looked at this object before. Every time, it was the same, faint, steady, uneventful. But this night was different. The images looked slightly off. The brightness, the shape, the data, something didn't feel right. And then he saw it, barely visible, so faint it could have been mistaken for noise, a line. Not part of the object itself, but extending from it, thin as a thread unraveling in the dark. To most astronomers, it would have been dismissed as a glitch, a background star, a processing error. But Jacques had seen enough anomalies in his career to know when something demanded a second look. He called in a colleague, Ari Marta, director of the Pleiades Astronomy Club. Together, they went frame by frame, image by image. And the line was still there, consistent, aligned, impossible to ignore. It wasn't noise. It wasn't a star. It wasn't a mistake. It was a tail. For the first time, 3I/Atlas, long thought to be a dead, lifeless rock, was showing signs of activity. But this wasn't just any tail. It was tilted at a bizarre angle, 102 degrees off the solar axis, breaking one of the most fundamental rules of cometary physics. And that was the moment everything changed. In astronomy, some rules are so reliable they're almost like laws of nature. And one of the most unshakable is this: comet tails always point away from the sun. Always. It doesn't matter which direction the comet is moving. It doesn't matter how fast or slow. The physics is simple. As a comet gets close to the sun, heat begins to sublimate the frozen gases locked inside it. Ice turns directly into vapor, pressure builds, and streams of dust and gas are released. Then the solar wind, a constant outflow of charged particles from the sun, blows that material outward, forming a tail that points straight away from the solar furnace. That rule is so consistent that astronomers literally use tail direction to map out a comet's orientation in space. It's not just a pattern, it's a compass written in light. But 3I/Atlas? It broke the compass. When Jacques and Marta studied their images, the tail wasn't trailing neatly away from the sun like every comet in history. It wasn't even close. Instead, it was tilted 102 degrees off the solar axis. A sideways streak, pointing in a direction that simply shouldn't exist. Imagine standing in a storm with the wind blowing from the east. Every flag, every tree branch, every leaf is whipped westward. And then, in the middle of it all, one flag streams north, completely ignoring the wind. That's how bizarre this was. To most observers, it would have been invisible. Because when astronomers look for comet activity, they follow the rules. They scan in predictable paths, check the space opposite the sun, and expect to find the tail there. But this time, the rules betrayed them. The tail wasn't behind the comet at all. It was hiding, skewed off at a strange angle, perfectly positioned to escape the gaze of even the most powerful telescopes. It wasn't invisible. We were just looking in the wrong place, and that changes everything. Because if the tail is real, if 3I/Atlas is shedding material in defiance of cometary physics, then this isn't just a dead rock drifting silently through our solar system. It's active. It's alive, in the cosmic sense. It's doing something we don't yet understand. And if it can break the most basic rule of comet behavior, what else might it be capable of? For years, astronomers had filed 3I/Atlas under one category, inactive. No outbursts. No unusual movement. No tail. Just another interstellar visitor, cold and silent. A fossil from some forgotten system, passing through ours like a ghost ship. But ghosts don't wake up. And that's exactly what happened. The faint line spotted from Brazil wasn't just a streak of dust. It was a signal, proof that something inside 3I/Atlas had stirred. Somehow, after drifting through the frozen dark for millions, maybe even billions of years, this interstellar wanderer had begun to shed material, like a sleeper shifting in their bed after an endless night. Scientists immediately scrambled to explain it. Maybe 3I/Atlas was coated in exotic ices, frozen substances we rarely see in comets from our own solar system. Perhaps those ices react differently to sunlight, venting in strange, unpredictable ways. Others suggested that the object could be rotating chaotically, exposing hidden reservoirs of frozen gas that suddenly boiled off into space. But there was a deeper problem. None of these theories explained the angle. Even if 3I/Atlas was venting strange ices, the tail should still have been pushed by the solar wind in a predictable direction. The laws of physics don't just change because a comet is exotic, which led some to whisper a far more unsettling question. Was this truly natural at all? Because if the tail was real, then something about 3I/Atlas wasn't just different. It was deliberate, controlled, perhaps even engineered. For decades, science fiction writers had speculated that the first signs of extraterrestrial technology might not be a glowing UFO or a radio signal from the stars, but something more subtle, an object masquerading as a comet, hiding in plain sight, until one day it did something impossible. And with 3I/Atlas, that impossible moment had arrived. But the awakening was only the beginning. Because what came next would shake the confidence of even the most skeptical astronomers. With the tail revealed and activity undeniable, the question became unavoidable. What is 3I/Atlas really? Theory 1 is the obvious. A comet from another star system. It behaves like one, sublimating under sunlight, shedding material, forming a tail. But the trajectory complicates that story. Its path is hyperbolic, slicing through our solar system at a speed no local gravity could contain. This isn't just a comet. It's a visitor from the void between the stars. Theory 2 is more exotic, a fragment of a destroyed planet. Some astronomers speculate that 3I/Atlas could be the crust or mantle of a world torn apart by cosmic violence, drifting alone for millions or billions of years before reaching our backyard. That strange, tilted tail? Maybe the residue of a chaotic origin, slowly releasing ancient materials that have never seen sunlight before. Then there's Theory 3, the one that keeps scientists awake at night. Something entirely new. A class of object that doesn't fit our categories, neither comet nor asteroid, neither dead nor alive. A hybrid, a cosmic fossil, a relic of a distant system carrying secrets we can barely begin to imagine. Compare 3I/Atlas to its predecessors. Oumuamua was fast, tumbling, no visible tail, a mystery that sparked global debate. Borisov was clearly a comet, blazing brightly, easy to classify. And now 3I/Atlas, somewhere in between, defying expectations, forcing scientists to question the rules themselves. Some whisper even darker possibilities. Could this object be a message in motion, a fragment carrying the chemical fingerprints of another civilization? Or is it simply a stranger from another system, indifferent to our questions, passing through silently until it vanishes forever? Whatever it is, one thing is certain: 3I/Atlas refuses to be simple. And as the Brazilian images spread across the world, astronomers realized that this object might challenge everything we thought we knew about interstellar visitors. And yet, even in this fleeting glimpse, there is something profound. 3I/Atlas didn't arrive with fireworks. It didn't crash into a planet. It whispered. A single line of dust and gas, angled sideways, quietly breaking the rules. But that whisper carried a message. The universe is stranger than we imagine, and discovery doesn't always come from power or technology. Sometimes it comes from patience, curiosity, and perspective. NASA told us what it was made of. Brazil told us what it did. Together, they revealed a story written in light, motion, and chemistry. And that story is still incomplete. Perhaps 3I/Atlas is a comet, a fragment of a destroyed planet, or a relic we have yet to name. Perhaps it carries the fingerprints of a star system long gone. Or perhaps it is a cosmic reminder that the universe doesn't explain itself, it invites us to look closer, to imagine, to wonder. And one day, billions of years from now, when another interstellar traveler drifts silently into our sky, we will remember 3I/Atlas. A faint streak, a tilted tail, a fleeting moment where humanity caught the universe whispering its secrets, and we listened.